our final video in this section, what we're going to do is have a look at how we can use our Maxwell-Boltzmann distribution to look at the effect of catalysts on rate. So remember that a catalyst, this is describing what a catalyst is. It's a substance that speeds up a reaction without being changed in chemical composition or amount. This is how it works, and what we're going to add is how it affects rate. So it works by providing an alternate route with a lower activation energy. It works that way, but how does it affect the rate? So the first thing I want to recap is from your energetics notes. Let's draw an energy profile diagram. This is not a Maxwell-Boltzmann distribution, this is an energy profile diagram. So remember that we put enthalpy up the side, that is our energy measure, and reaction progress along the bottom. Now we could have two of these, but let's just do it for an exothermic reaction because that's more common. So let's have a go at an exothermic one where we start off up here and we end up over here. We can write our reactants on one line and our products on the other. And we can draw a curve, and we know from our previous study that if we go from the level of the reactants to the top of the curve, we call that the activation energy. So how would we show the effect of a catalyst on this? Well, what we do is we provide an alternate route from reactants to products that has a lower activation energy. So EA catalysed is a lower value, a smaller value. Does that affect the value of delta H? Well, no. The reactants and the products are still the same distance apart. We're just affecting the size of the hump that we need to get over. Okay, so delta H is not changed, but our activation energy was lowered. Right, how would we put that on a Maxwell-Boltzmann distribution? So what I want you to do is redraw your original Maxwell-Boltzmann distribution. So remember, we're starting at the origin and our peak is to the left. And we know that our activation energy is occurring over here somewhere to the right, and that we can shade in that area. Now, when we add a catalyst, we provide an alternate route of lower activation energy. So we're moving the activation energy line left. Be careful, it must stay to the right of the peak. It can be moved left from where it was before. And notice that your shaded area is now an awful lot bigger. Many more particles have energy greater than or equal to the activation energy. More collisions are successful. So how does a catalyst affect rate? Describe that in terms of activation energy. And that is the end of the videos on the Maxwell-Boltzmann distribution.